Hello everybody. In this video we are going to walk through the embedded system design workflow, the step-by-step process engineers use to go from an idea to a fully functional embedded product. Whether you are building a smart sensor or a robotic system or even an IoT device, understanding this workflow will help you to design efficiently and avoid common mistakes really. Let us dive in. 1. Requirements analysis. You have to know that every good design starts with a clear understanding of what you are building. In this phase, you define the functionality, performance goals, even the constraints of the system. This is where you might ask questions like, what should the systems do? How fast should it respond? What are the limits? This step lays the foundation for everything that follows, and skipping it usually leads to costly redesigns later. Number 2, system design. Once the requirements are clear, it is time to design the system architecture. Here you will decide on the hardware components such as the microcontroller, the sensors, the actuators if you are going to move certain parts, the communication modules. Also, you need to define the software architecture, how you are going to structure the code. Here, you have to decide whether it will be a bare metal system running without an operating system, or you are going to use real-time operating system for things like multitasking and timing control. This is where you define the building blocks of your embedded system. Number 3 is hardware development. You are going to make schematics, design the PCB layout, and then build a prototype. This stage often involves using CAD tools like Artium, KeyCAD, Ego, anything to bring your circuit to life. Now, once the prototype is ready, you can move on to testing and validating that the hardware works as expected. Number 4, software development. While the hardware is being developed, the software development usually happens in parallel. This is where you write firmware, device drivers, application code that will run on your microcontroller. Here you get to use tools, integrated development environments like STM32Cube IDE or Sega Embedded Studio. Some people even use Arduino or Cal. And we use these IDEs along with debuggers such as JTAG or SWD to program and test the firmware. Number 5 is integration. This is where you combine both the hardware and software and start testing how they interact with each other. You are going to verify communication between respective modules through interfaces like the UART, SPI, I2C, or even CAN protocol if you are developing for automotive systems. And you will make sure that everything works seamlessly together. This stage often reveals hidden bugs, so be ready to do some debugging and iteration. Number 6. After the integration process, the system goes through testing and validation. Here you verify that your system meets all the functional and performance requirements, including real-time deadlines if you have any, or maybe reliability requirements, or even safety compliance if you are building for critical applications. It could be in automotive or even medical systems. You might use tools like the oscilloscopes and logic analyzers, or even simulating software to observe signals and ensure that the system behaves as expected. Then we move on to optimization, because once everything works, you have to optimize, refining the design to improve power efficiency, memory usage, and overall performance. For example, you might reduce CPU load, lower power consumption, or optimize your code for, let's say, faster execution. Small improvements here can make a big difference, especially for battery-powered or resource-constrained systems. So you need to optimize your code well. Whether you have some redundant loops somewhere, you could replace them with an if statement, whether you can write smaller expressions, etc. Everything is done and we want to deploy, right? So this is where you move from building prototypes to probably mass production, right? So it will involve programming the devices, testing them for quality, and deploying them into the field. Now, even after deployment, something that you need to know is that engineers continue monitoring performance and providing updates when needed. It's an important part of deployment, ensuring that your device keeps on functioning as expected in the field. This gives you a good reputation. There are some key things that altogether you need to consider, right? Throughout all the stages, you have to remember that embedded system design is an iterative process. It's not a one-time thing. You need to do it over and over again. You will debug and refine your system multiple times before it's perfect or even good or functional. Now, you have to use the right tools. I cannot stress this enough. You have to use the right tools, from IDEs to debuggers to oscilloscopes and power analyzers, logic analyzers. You employ all these tools to ensure that the process is convenient and effective as much as possible. Always consider compliance and safety standards, especially those building for critical areas. If you are building a do-it-yourself project, you might not focus on the safety standards and compliance, but in the real world, we need to consider safety standards. That was a quick overview of the entire workflow for designing an embedded system, from concept to deploying the physical product. In the next video, we are going to start from an idea and build a physical product from ground up. I promise this is going to be my best video so far. After watching this series of videos, you should be able to start from your own idea, whatever it is. Gather the right tools, the right sensors, design your own schematic, build your prototypes, do testing, validate, and finally come up with a functioning product. It's going to be exciting, and I will see you in the next video. Don't forget to subscribe.